Z-test can be used to compare the means of two samples. Okay, so means of two sample can be compared by the Z-test whether two sample means are equal or not. Okay, equal or not. So this is can be test done by Z-test. So here I put the one example. Do you know the fat, saturated fat, which is not good for our health? So for the two sample, so for the true brand commercial frying fat we are given for the sample we got A and sample B, and from sample we take the 40 sample, and for the B we took the 50 sample, and the average of such saturated fat is found for the sample A or company A 6.02, and for the sample 2 or B we got 6.41, and for the sample A is standard deviation is given 0.86, and sample B standard deviation 96. Now we want to there is some difference, but whether the saturated fat among the two sample is same or different, how can we test? Two brand here. Okay, brand is A and B. Whether name or not, we can do it by Z test. Okay, let us see how to solve this problem. First of all, we have to say two fats are equal. That is the fats for the brand A and fats for the brand 2 are equal. And alternate hypothesis, they are not equal. Okay, maybe more than or less than. So first of all, step one, we formulated the null hypothesis that we have to say there is no difference between the fat between the two brands, and already we have to say there is difference. Okay, HA on H1, they are not equal, they are different. And see, remember, and the second step, as five, I think level of significance is not given. I told you it is not given. You have to take 5%. So alpha equal to 0.05. We have to take the level of significance 5%. And remember the formula, please. If you want to test the two names equal or not, you have to use the Z statistic like that. Okay, x1 bar minus x2 bar, then minus mu1 and mu2. And x1 bar is the mean from the sample 1 from the brand 1 you got. X2 bar is the mean from the sample 2, and the population we don't know, but normally mu1 minus mu2 will be 0. Okay, because we agree, first of all, we agree that uh, two means are equal. So we have to, if equal, then mu1 minus mu2 will be 0. Okay. So, and what is the sigma 1? Is the variance of the first sample, which is brand A, and sigma 2 is the variance of the second sample. Okay. So this is from the brand 2, and N1 is the sample from the brand A, and N2 is the sample for the brand 2. So we know all the value. X1 is 6.02, X2 bar is the 6.41, and mu1 minus mu2, I told you, depend upon the null hypothesis, mu1 and minus mu2 will be 0 always. And sigma 1 is square, you know, the standard deviation given 0.086. So sigma is square, we have to square it, we will get the value. And sigma 2 is square, as the standard deviation of brand 2 is 0.09 square. And you know the sample for the first one is 40, and second one is 50. So 40 and 50, if you put all the value, we'll get the value of Z from the test statistics minus 2.093. As it is two tail test, I told you always we take the positive value. So value of Z will be 2.093. So we have calculated value of Z from the test statistics 2.093. And the step 4, by conventional method, you have to find the critical region. We know at 5% level significant, critical region for Z test will be greater than 1. I wrote it equal to greater than or equal to 1.96. So we got the critical region. I know it 5% level 1.96. Now step 5 calculation. So our calculated value of Z is 2.93, but critical region more than 1.96. So our value fall in the critical region. Our 2.093 greater than 1.96. That is, it falls in the critical region. When it falls in the critical region, we do not accept the null hypothesis. We reject the null hypothesis. That is, we reject the null hypothesis, accept the alternative hypothesis. That is, there statistically that the fat, saturated fat of the two brand A and B is not equal. So That is, you can say from the test of statistics, at 5% level of significance, they do not, the two brands do not have the equal amount of saturated fat. So this is by conventional method. Let us try by p-value method. Okay, p-value, we know we have to get the probability greater than our tabulated value plus value 2.09. Okay, and multiply to 2. Okay, let us see the p-value method. I do it. So p-value, I told you 2 multiply greater than 2.093. So if you go the table, I told you when greater than 1 minus less than. Okay. So if you use the table 2.093. Okay. Let us see in the tabulation whether it is right or not. 0.9817 for 2.093. Okay. Z less than 2.093. Let us see in the table. Z less than 2.093. 2.093. I cannot give the 0.93. It is 2.09 is 9817. Okay. So I think I put that approximately 9817. I put that value for you. Let us check it. Yes, 9817. So our tablet, we can 2 decimal 2.09. So tabulated value of Z for less than 2.09, 9817, multiply minus from 1, multiply 2, you will get it 0.366. So our p value, finally we get 0.366. Now we know that if p value less than 0.05 for 5% level significant, we reject the null hypothesis. Now what is our p value? 0.36 less than 0.05. So we reject the null hypothesis. Same as the conventional method, it fall in the critical region, reject the null hypothesis. That is the fat, saturated fat in the true brand is equal, we don't accept. We accept they are not equal. So as our p value less than 0.05, we reject the null hypothesis, accept the alternative, and conclude that saturated fat in the two brands are not equal. So same thing. So you can use any method, conventional critical region, or maybe the p-value method, but you will get the same answer and same conclusion. Okay, this is the way how to compare the two means by Z test.